Hello everyone. On this video, I'm going to go over a very important macroeconomic problem, which is inflation. So we all know that prices increase over time, and it's actually a fact of life, right? So the prices of most goods and services, they do rise over time, and which we call it the cost of living. So the cost of living goes up over time. So when you compare the prices of goods that you used to buy maybe in the 1900 is not the same as the goods that we used to buy in 1950, is not the same as the prices of goods that we used to buy now. So the prices do change over time, and this is our topic today. So inflation is defined as the percentage increase in the price level and over a specific period of time. So let's say from year to year, you can say from one quarter to another. It has to be during a specific period of time, let's say from year to year. It is computed by the Bureau of Labor Statistics. They do surveys in order to provide us with a measure of inflation. So it's a percentage, as I said. So to be specific, we call this definition inflation rate. So inflation rate is the percentage increase in the price level over a certain period of time, usually from one year to another year. There is another definition which is called deflation, which is simply the opposite. So you can just repeat the whole sentence and say it's the percentage decrease in the price level, again over a specific period of time, from year to year, or from quarter to quarter, or from month to month. It depends on what you want to measure, but this is the definition. So deflation rate. Okay, so this is related to deflation. So in both definitions, we are talking about something called price level. So what is a price level? The price level is a measure, it's a measure of the average prices of goods and services right? I'm gonna always write it as GNS just for simplicity, in the economy. So it's a measure of the average prices of goods and services in the economy. Of course, when I say goods and services, it's kind of a broad definition. Like we haven't specified here. Are we talking about consumer goods and services? Are we talking about producer goods and services? Or are we talking about all goods and services produced in an economy during a specific period of time? So when we look at the goods and services, we can come up with three measures depending on the definition of goods and services. If it is related to every good or goods and services, or let me be more specific. So if it is related to every final, it's not an intermediate, goods and services produced in the economy during a specific period of time, usually we say 1 year, for example, 1 year. This is called GDP deflator. Okay, so this is our first measure of inflation. So GDP deflator is based on gross domestic product, and we know already that by definition, gross domestic product includes only the goods and services that are final. We don't include anything that is intermediate. Okay. If we define goods and services as consumer goods, then this is called the consumer price index and known as the CPI. If we define the goods and services as those related to the producer, right? So this one is called the producer price index. Okay, PPI. All right, so let me go over each one in details, or a little bit more in details, and we are going to focus on the CPI, or the consumer goods and services. So the first one, GDP deflator, it is a measure of inflation, and it is considered as the broadest measure because it includes everything final, right, produced in the economy. So it includes whatever you can think of, every final good and service. Okay, so it is too broad. It's not good. Like, this measure is actually not the best. It's not good. If I want to measure the impact of the price change on a typical consumer, right? Because it includes so many things that I really cannot consider it as directly related to the consumer. Okay, so for example, when you say that you have large electric generators, these are not directly related to the consumer. Okay, however, these are important, yes. They are part of the final goods and services produced in the economy within the year, yes, but they are not directly showing me the increase of prices on the consumer, which we are concerned about. Our second measure of inflation is the consumer price index, or the CPI. And this is, again, the Bureau of Labor Statistics. What they do is they actually do a survey. Okay, so they try to do a survey based on a sample, and this sample includes 30,000 households. Okay, so 30,000 households, and this is nationwide. Okay, and what they do is they ask the households about their spending habits. Okay, so what they typically buy when they go to the supermarket. So they do ask about their spending habits. And we can define the CPI as, so the CPI, or the Consumer Price Index, CPI is defined as the average of prices of goods and services that are purchased by the typical urban family of four. Okay, so family of four, so the parents and two kids on average, this is the typical family, and we want to know what is their average price, what is the average prices of their baskets. So if you go to the supermarket and you buy eggs and milk and cheese and many other things, and you probably also buy services like haircut and so on, like a typical family of four, typical urban family of four, how much would they spend, and what is the kind of basket that they would come up with, let's say during the months. So this is a measure of cost of living. Okay, so let me give you an example here. So suppose that we have an economy which is very simple economy, where we have only three products. Okay, so we have product X, product Y, and Z. And suppose that, and these are the ones in the typical family of four basket. Okay, what they buy when they go to the supermarket, they would buy good X, Y, and Z. And you also ask them in the survey how much you buy from each of these products. So let's say they say, okay, 1 unit, 20 units, and let's say 20 units. So what you need to do is, or what the BLS does is, they actually want to compute the expenditure. So suppose that the base year, which is our reference year, the base year is 1999. And suppose that the base year prices are $50 per unit for X, $10 per unit of Y, 25 unit per unit of Z. So you want to compute here their spending or expenditure. So what you do is, expenditure is simply the price times the quantity. So 1 unit times 50 is just 50. 20 units times 10 is 200. 20 units times $25 is 500. And it's very important to keep the dollar symbol here so that we're not confused between the units and the value or the dollar value. So the total spending for a typical family of four in the year 1999, you add up all these together and it's 750. All right, so this is just for the base year. But in the definition of inflation, we said it's the movement from 1 year to the next, right? So when we go back here, so from 1 year to year. So what we have in this example is just 1 year. So we need a comparison, right? We need to compare what happened to prices over time. So when we take the prices of another year, which is 2010, for example, again, we have a price that is changing over time, and we have expenditure. The most important thing to remember or to note is the BLS have created a basket, and this is their basket. Okay, so this basket is fixed from 1 year to the next, and the BLS, they do not change it every year. Okay, they used to change it every 10 years, but nowadays they used to change, they do change it every 2 years. So suppose that we have the same, assuming that we have the same basket, so people in 2010 are using the same basket that they used to have in 1999. So the prices do change. So suppose that these are the new prices in 2010. Now I want to compute the spending. So the spending is going to be the quantity times the new price. So 1 times 100, it's 100. 20 times 15, it's 300, right? And then 20 times 25 is 500. And then we again add all these up, and this would give us the spending by a typical family or a typical urban family of 4. Next, what happens in 2011? So assuming that we keep the same basket, so our quantity is going to always stay the same. So this column is fixed all the time. We are using same basket, okay? So the survey uses the same basket. If you say I go to the supermarket every month and I buy just one can of beer, or one box of milk, or one carton of eggs, it's going to stay the same and the same. Okay, so it's the same basket. So now in 2011, assuming the same basket, we still have different prices. So suppose that these are 85, 14, and these numbers are given to you in the question. These are you will not be asked to come up with prices because we have to give you the prices. And expenditure is the one that you would have to calculate by computing the multiplication between quantity and the new prices. So 1 times 85 is 85, 20 times 14 is 280, and then 20 times 27.5 is 550, and this is our new total spending, 915. The numbers that we have computed are very important. So comparing the spending value in 1999 versus 2010 and 2011 versus 1999, and this is our base year. Base year is our reference year. So if I want to compute what happens to prices from 2010 to 1999, I have to compare these two. And if I want to compare what happened to 2011 versus 1999, I'm going to be comparing these two. Okay, and all the time you will have to refer to your base year or the reference year. So how can we compute the inflation rate? So computing the inflation rate, we have a specific formula. So the formula is number one, I have to get the CPI, Consumer Price Index. It's just an index, okay? It's not measured in dollars or any other units. So it's equal to how much they spend in current year divided by the expenditure in the base or the reference year. And you multiply this times 100. It's an index. Okay, so when you want to compute the CPI in 2010, you get the spending in 2010, which is 900, over the spending in the base year, which is 750. Okay, you take this, you multiply times 100, and you get as 120. CPI in 2011 is equal to the spending or expenditure in 2011, which is 915, over the same number, right? Because the reference year is the same, times 100, and this would give us 122. I want you to notice that these numbers, again, these are not in dollars. So these are not measured in dollar or in any other unit. Okay, so this is just unitless. Okay, now how can I compute inflation? So inflation, as we said, it's the percentage increase in the price level. Based on the definitions of CPI, so we can say it's the percentage increase in the consumer price index. So if I want to compute inflation rate, okay, and this is rate, in 2011, it's equal to, this is 2011, right, versus the base year. So it's going to be equal to 122 minus 120 over 120. Okay, I'm sorry, it's not the versus the base year, versus the previous year, okay? So how much I have increased over the year from 2010 to 2011. And then you take this number and you multiply times 100 and you get the number as 1.7%. What does that mean? 1.7%, this is point, means that there is an increase by 1.7% over the year from 2010 to 2011. Okay? So prices, or the average, you can write it here, the average price level has increased by 1.7% from 2010 to 2011. And again, just notice that what is our measure of the average is the consumer price index. Okay, so there are many disadvantages of using this method, which is collecting a basket of goods that are consumed by a typical family of four. Sometimes this is not accurate, okay? So why it is not accurate? Okay, so computing the inflation rate based on what I've just described is not accurate. So when you think about it, the BLS, what they do is they find a survey, right? As I said, 30,000 households. They ask them about their spending habits, and more specifically, they do create a basket, right? And they try to put in this basket all the goods and services produced by consumed by a family of four. So one of the important disadvantage of this method is something called substitution. I'm sorry, so let me just write it. Substitution bias. Okay, so there is a difference between the actual inflation and the computed inflation based on what I've just described, the method that I have just described, because the basket here includes goods and services, right? Let's say I have here good X, and it's gonna stay in this, X is gonna stay in this basket, right? And it's gonna stay, it used to stay in this basket for 10 years, okay? So the BLS, they will not change this basket for 10 years. So now suppose that the price of X has increased. We all know that if I can find a substitute for X, I would not buy X, right? Suppose that you have good Y that is a good substitute, right, for X. So what you do, if the price of X goes up, then you would consume less X and you would consume more Y. Okay, so now Y is not in the basket. So when I increase my demand for Y, it might be reflected in the price of Y. It might increase, right? And if I reduce my demand for X, the price of X might decrease. But however, what is inside the basket is a reflection of the price of X, but the price of Y is outside, despite the fact that consumers might have already switched to this good substitute. Okay, so substitution bias, let's say if X and Y are substitutes. Okay, suppose that X in the basket of the consumer price index. So it's in the basket of goods, however, Y is not, right? The problem is as the price of Y relative to X, or relative to the price of X, decreases, so the price of Y is going down, okay, what's gonna happen is consumers buy less X and more Y. However, the CPI use the same basket, so this behavior of consumers of switching from one good to the other one, given the increase in price or their ability to substitute, is not reflected in the basket. Okay. The other thing is called the outlet bias. So the basket here that we collect from the survey, or the BLS collects from the survey, just includes the full price of retail stores. So everything that you see here is just the retail stores, full price. They don't include any discount stores. And we all know that starting 1990, consumers have started to purchase from discount stores like Sam's Club, Costco, BJ's, and so on. However, these are not here. Here are only the full price discount stores. Full price retail store. Okay, so the outlet bias is a problem because we have seen it like starting 1990. Consumers, they have increased purchases from discount stores. So that means this is not reflect. Discount stores are giving us like discounts, so the prices should be lower than what we see represented in the CPI. Okay, and also we have online shopping, right? And also we purchase over the net. It's not included. So purchases over the net or online are not also included in the basket. Okay, the CPI is just continues to calculate a basket from regular full price retail stores. Okay, so this is not like, and this would lead to an overestimation, right, of inflation. So it's an overestimate. Whatever I see is higher than what is supposed to be. Same thing here. If the price of X goes up, it's still there, right? So substitution bias also might lead to an overestimation of the price or the average prices of a typical family of four, given that the basket is not updated. What else? There is also another problem, which is the new product bias. So given that the BLS used to update it to update the basket only every 10 years, if I have a new product in the market, it is not included until the next update. Okay, so for example, the CPI basket was updated in 1987, 1997, 2007. Anything that happens between these 2 years are not included in here. Anything happens between these two here are not included in the 2007 basket, and so on. Okay, so there is a problem because here, for instance, we used to have like cell phones, right? So many Americans started to have cell phones, and cell phones, typical family of four were spending on cell phones. However, this was not included in the basket until the update that happened in 1997. So many products, after a few years of being introduced in the market, their prices fall. This price is not included in the CPI. So it might be the case that when the cell phone was first introduced, had a certain price that was higher than when it started to be included in 1997. Okay. What else? Our last problem is called the increase in quality bias. So again, the computation of inflation based on the basket of a typical family of four might lead to some biases. Bias is the difference between the actual and the computed level. So we already know that if I see a high price, it might be an indication of a good quality. So are you looking for a lower price and bad quality, or you would take the high price given that you would also be taking a good or a better quality? So we know that better quality is reflected in higher prices. So it might be the case that higher prices is not a bad thing, right? So we know that higher prices might be the increase in prices might be because of the pure inflation or price inflation, which we try to avoid, or because of better quality, okay, or a mix of both. Okay, so we care about this one, right? We care about like the BLS, they do compute this one. They care about the price. They really don't tell us anything about the quality, right? So the BLS do adjustment, and the result of the CPI is basically kind of overestimated. So when they try to capture all these different types of biases, the problem is these four biases would make up something around 0.5 to 1% of inflation rate. Okay, so the four types of biases that we have just talked about has been estimated to be around 0.5% to 1% inflation rate. So whatever, like, it's not a huge number, right? It's not like a number that we really should find it as a problematic because we cannot estimate it. As long as it is within 0.5 or 1%, then statisticians, they find this okay. So if the announced level of inflation, let's say, is 7%, for example, so usually people would think about it as, okay, just subtract, it's between 6% to 6.5 if I take rid of the bias coming from the different types of biases, whether a substitution bias, new product bias, quality bias, and so on. Again, to overcome these different types of biases, the BLS started to update the basket every 2 years instead of every 10 years. This is one of the things. They have also started to use statistical methods that can capture the quality bias. Okay, so the quality bias is they're trying to capture it in somehow in certain statistical softwares, and in a hope that to minimize this range as much as possible. So instead of having it between 0.5 and 1, minimize it as much as possible to maybe 0.5 to 0.6, 0.5, 0.7, as much as possible, minimize this range. Okay, before I end this video, I'm going to talk about our third type of inflation measure, and this is called the producer price index. And the producer price index, PPI, producer price index, that I have introduced at the beginning of today's video, the producer price index, as the name suggests, and I'm sure that you can expect that, it's actually made out of the goods that are related to the producer, right? So anything that is intermediate good, right, so is included in this measure, and you can define it as it's an average of the prices received by producers of goods and services at all stages. So you can think of it as the intermediate goods, okay? All stages of the production process, okay? So, for example, any increase in raw cotton, which is an intermediate good for a t-shirt, you would expect that the price of a t-shirt would also go up. So any increase in intermediate good implies an increase in the price of the final good. Okay, so that's why people think of it as an early warning about what's going to happen for the prices of the final goods. So PPI is used as an early warning. And I want to give you one example, and I said raw cotton, for example. So raw cotton, and you're talking about a final, so it's the t-shirt. Okay, so when I see that prices of raw cotton has increased, then I would also expect that the price of t-shirts would go up. For the sake of completion, just let me add one formula here, which is the GDP deflator, because I already have it for you in one of the previous videos, but let me just have it here. So the GDP deflator formula, let me write it here. It's actually equal, so GDP deflator is equal to the nominal GDP divided by the real GDP times 100. Okay, and this is the formula used to compute the GDP deflator. It's a rate again. It's not a rate, it's an index, not a percentage. Okay, so it's an index similar to the idea of the CPI, and then as you compute, you computed exactly like what we have done here. You would be computing a deflator for 1 year, a deflator for another year, and the inflation rate would be the difference between two deflators. Okay, so for example, when I say what is the, let me write it here. So when I say, for example, what is the inflation rate in 2011, which means that I want it over the year from 20, let's say 10 to 2011, then it's going to be equal to the GDP deflator, or the change in GDP deflator, right, over, okay, the original one. So it's going to be like the change from GDP deflator of 2011 minus the deflator of 2010 over the deflator of 2010, and then you multiply it times 100. Okay, so I'm sorry it's like too tiny, but I'm depending that you already have seen it in the previous example on the GDP deflator. All right, everyone, I'm gonna stop here, and if you have any question, let me know.